Welcome to clickmyproject.com. Let me discuss the project about classification of multispectral images by fuzzy and neural network approaches. In this paper, we proposed the hyperspectral image provides the potential for more accurate and detailed information extraction than possible with any other type of remotely sensed data. Heavier classification of a hyperspectral image is a quite challenging task due to a very high dimensionality in order to account this band's data. The high spectral resolution of a hyperspectral image allows for detection, identification and quantification of surface materials, as well as it includes biological and chemical processes. Ground pixel sizes of the sensor is then multispectral system, so all pixels are in mixed class type. Spectral mosquito analysis is done by two methods. Hyperspectral classification is done by with spectral matching techniques, which is best method, and pixel purity analysis with spectral unmixing logarithm is second method. Now spectral similarity can be measured between spectral signatures of image pixel and spectral signature of target pixel using spectral matching technique. It's the block diagram of our project. First we will load the input hyperspectral images, then next pre-processing. Pre-processing is the first step is performed before the feature selection, feature extraction and classification of the information from the images. The pre-processing steps are classified into two, then the radiometric correlation and atmospheric correction. Radiometric correction is the made to the raw digital image data to correct for brightness values of the object on the ground that have been disordered because of sensor calibration problems. This hyperspectral level is data is radio corrected. The next one is atmospheric correction. Atmospheric correction is the travels from the sun to the earth's surface and then the sensor. The intervening atmospheric often sectors some light. Therefore, the light received at the sensor may be more or less than that due to the reflectance from the surface alone. The next one is band selection. Band selection is the uses mixed measure of high order moments and spectral decorrelation measures as well as spatial decorrelation measures. It is expected that these bands with larger skewness contain important target information and should be selected, and band image are rearranged on the order of high order moments. Band divergence is used to reduce the spectral redundancy, and band spatial decorrelations is used to reduce the spatial redundancies are used to select their bands. The next one is classification. Classification is used to the hyperspectral images to select the most distant but informative bands. Water absorption and low SNR bands are needed to be pre-removed. If the noise component is larger, a band may look more different from others, although it may not be uniformly distant. So it is prerequisite to consider these factors for the input bands. The removal of bad bands and noise are carried out manually. The subset of a particular land use image is given as input. Then the used to the feature external skewness divergence. Skewness is the band image with larger high order moments contains useful target information and should be preserved. The skewness of each band image is calculated. Intensity range is each band, then how the data are distributed around the mean. The next one is divergence. Divergence feature extractions. A band image with larger high order moments contains useful target information and should be preserved. Since the band prioritization, consider the spectral correction or a band decorrelation using the divergence is used to decorrelate priority bands. The number of bands selected depends upon the threshold value. Finally, output classified image. Output classified image is the loss divergence and less correlation, then less divergence and high correlation, then high divergence and less correlation, high divergence and high correlation. All the four steps while selecting bands we have to consider the third steps only. Then the classification process is spectral curve catching. Finally, correlation value is plotted against divergence value. Then the spectral dissimilarity and spatial similarity between the bands. High divergence represents low spectral similarity. Sometimes high divergence has high spatial correlation value. So we have to consider the correlation coefficient while selecting the bands. Now let's see about the execution part. I am having band main.m file. Select the file, right click, then run file. Here we have to select the hyperspectral images. Then you are selected to the band 1, band 2, band 3, band 4, band 5, band 6, then band 7. Then methodology for band selection. This new and band selection methods uses mixed measure of high order moments and spectral decorrelation measures, pixel based as well as spatial decorrelation measures, image based. It is expected that these bands are very useful to these spatial decorrelation measures, and this that bands with larger skewness contain important target information and should be selected, and spectral redundancy and band spatial decorrelation is used to reduce spatial redundancy are used to select the bands. When the measure is applied to hyperspectral image, which is generally occurred with more than bands or 7 bands, such as direct calculations becomes difficult. In order to remove these problems, an alternate methods is investigate the distance. So it is pre-requesting to consider these factors for the input bands. The removal of bad bands and noise are carried out manually. The subset of a particular land use image is given as input. This is the classification or spectral curve generation at different wavelength interval using variable interval spectral average method. Spectral curve matching is used to do this classification process. Then water area, then land area, then river area, and this one is less divergence and high correlation, and this one is less divergence and high correlations for, then this one is high divergence and less correlations, and then this one is input for the 7th and bands. Then the band selection skewness is a measure of symmetry, or more precisely the lack of symmetry. The distribution is symmetric if it looks the same at the left to right the center point. The skewness value for each band is calculated as skewness 0 value represent that band has more or exactly homogeneous values. Correlation value is plotted against divergence values. Then this is the final classification output. It's the skewness. A band image with large high order moments contains useful target information and should be preserved. Skewness of each band image is calculated. Intensity range is each band, then how the data are distributed around the mean. Then the next one is divergence. A band image with larger high order moments contains useful target information and should be preserved. Since the band prioritization is considered the spectral correction, a band color reduction using the divergence is used to decorrelate prioritized bands. The number of bands selected depends upon threshold value. If the divergence between two bands is below a preserved threshold, the band with lower priority is removed from the list of bands. Sometimes high divergence value have less correlation. We can note high divergence value in above graph, but it has high correlation in below the graphs. So we have to consider correlation coefficients when you select bands for hyperspectral images. Correlation coefficients is the 4 types of our. While selecting bands, we have to consider the steps. Then the spectral curve generation at different wavelength interval using variable interval spectral average method by classification. Then the spectral curve classifications matching is very useful to generate this process. Finally, when the measure is applied to hyperspectral image, which is generally occurred with more 7 bands, such a direct calculation becomes difficult. In order to remove these problems, an alternative method is instead of computing spectral decorrelation, divergence and spatial decorrelation for all possible combination of bands with high order moments can be done. Thank you.